All right. How is everyone doing? Awesome. Let's do a quick mic check if you can hear me all right. Hi, everyone. Let's wait a couple of minutes. Oh, hello. Hello. I see people joining in. Hi. Hi, Macaroni. Hi, Crypto. Amazing. Awesome. So, um, welcome to day two. If you were not here for day one, we have the recording. You can check it out later. But today is going to be very smooth and slow. I'm gonna make sure I answer your questions. We follow along pretty well. And today we are finally going to deploy our application that we made yesterday to Kubernetes. I'm so excited for that. Are you all? Awesome. Hi, Yogita. Hi, Vani. Great buzz in the chat. That's great. Amazing. All right. So if you had not caught up, I had created a GitHub repository for all of you. Let me just drop it in the chat. It's also in the description if you're watching us from YouTube, but I have dropped it in the chat. Hi, Manshu. There's all the resources from yesterday. I'll also push the resources that you need for today once you're done with this. But yeah, most of the stuff is here. If you feel like you want to follow along with me, feel free to clone this repository and you can just follow along. Or if you don't, that's fine. You can just watch and follow at your own pace. That also works. You see a Blahaj? Wow, you have a really nice eye. Wait, let me see. Yep, there it is. We have Mr. Blahaj watching us from behind, making sure the event runs smoothly while I handle the stream. So this repository should have most of the stuff, including the slides for today at the bottom, and any extra resources, I'll add it as we go through the stream. Cool stuff. So let's go back to slides because why not? Awesome. Today, it's going to be pretty simple. I'm just going to do a quick recap of what we did yesterday. And we're going to make sure if you had any questions or any issues while trying it on your own, containerizing your own application yesterday. Let's see if you can fix it today. And today we are going to resume our application. So yesterday we completed containerization. We pushed it to Docker Hub. Now today we are going to deploy our image to the Kubernetes cluster. And what is all that jargon? I'll explain that right now. But before that, a quick recap. Infrastructure is based of two types. So we have monolithic structure, microservices. Monolithic, where all the application is put in a single repository, in a single container. So it's like how you make zip files. So if you send your program to your friend, could be an application, could be a Python script, could be a website which has front end, back end, and database. If you store all that in a folder, convert it into a zip file, you're making a monolithic application, a monolithic infrastructure, right? Hi, I'm Alex. We are just recapping yesterday, what we learned yesterday, and just talking about monolithic services. Once again, monolithic service has everything inside a single container. Hi, Joshua. Thank you so much for joining us. Awesome. Amazing. I see great buzz in the chat. Okay. So the problem with monolithic services, if I want to update the database, I have to take everything out. I have to hold off the deployment. And that can be cost incurring if it's a business. So the problem with monolithic services is when you want to update a certain portion of it, could be a database, could be backend or front end, or if a service goes down, the whole structure comes down, the whole application comes down. This is where microservice comes in. Each of that service works on its own. It is its own application, and it talks to each other via APIs or application programming interface. It's a very popular tool to communicate between services. The advantage of microservice is if one thing goes down, other does not. I can make changes to one of the service and it won't affect others. So that keeps the wheel going even though I'm making changes to my application. So pretty popularly you see it in Instagram or on social media networks, which constantly update without even letting you know, or no service goes down while a part of it is working on it. So hi Tawkir, uh, so nice to see you join us. That is monolithic and microservices. I hope that makes sense. Now, next we did was containerization. That is super important for Kubernetes to work. Containerization is simple as, taking a bottle or taking a box and putting everything that you want to your friend. So yesterday I gave an example of coffee. I believe I create a very nice coffee, and Tawkir here, asks that, hey Ashwin, I really like your coffee. How can I try that? So a couple of ways I can do that is, one, go to Tokyo's place and gift him the coffee by my hand, which is very tedious. The second is I tell the recipe to Tokyo. But the problem with sharing a recipe is Tokyo might have different might have the same recipe but different ingredients. What if the brand of sugar tauke used is different, or the size of the tablespoon is different? That can really mess up the coffee which I wanted tauke to try. And containerization is, I pack the ingredients myself and just ship the box to Turkey. They just have to open it and mix the ingredients. That's it. They'll get the exact same experience no matter what container they're using, what mug they're using. They will have the exact same experience of coffee. That is what containerization is. Container takes a snapshot, like a photo of the application that you have. Snapshot, we also call it an image. Image, why? Because it has the exact same replica of your application. So it is literally the copy of your application, and then you can ship it to anyone and it will have the exact same image. That is one of the reason why images are so big in size even for smaller applications, because they have everything that you need. That removes the need for operating system requirement. So if Taukik here is in Windows or Mac and I build it on Linux, I don't have to worry that they have to make some changes for my application to work. Or in the coffee example, I can say, if I make it my kitchen, it does not matter what kind of kitchen and the tools Cake has, it will still work. The coffee will be great. So that was containerization. We used Docker, a very popular containerization tool, to containerize our very simple web application. A single HTML page, a web app which has a backend on Node.js server. You need a server for Docker to work because it all runs at the backend. So Nginx, Node, Python Django, or Flask, anything works, which runs your website on a server. So we containerized the app. I pushed it to Docker Hub, which is like GitHub. So GitHub has all your code. Docker Hub has all the Docker images. The only the difference is, like, GitHub has all the code you can see, and Docker has the whole image inside. It's a single file. So that was containerization, and we talked a little bit about Kubernetes and container like orchestration of containers. Orchestration is again like controlling and like commanding what to do with the containers. So who does that? And that is where Kubernetes comes in. Very good analogy is FIFA is going on, football is there, but the players don't play. Players are not the key element. It's the coach who instruct the players. Coach is the one who puts the strategy to win. So where should each player go, be placed, or what should be their position, or if one player is injured or is out of the game, do you replace them with a new player, or do you change the fielding of all of your team? What's the right strategy, right? So that is the work of a coach, and this is where Kubernetes is the coach and the containers are the players. So Kubernetes orchestrates, or basically instructs, all the containers to move up and down, and depending on what type of application we are working on. Today we have already done A and B, and we are going to uh, run our container in Kubernetes. And for that, we will try some new stuff called YAML and stuff. I'll go into that. But today we will be understanding what YAML is, which is required to set up the Kubernetes, and we will deploy our container to Kubernetes. Simple as that. And feel free to follow it along. I'll go really slow today, I promise. Just let me know if I'm going too fast, or even if I'm going too slow. And with that said, let's jump right in. Feel free to ask any questions. I have my chat open right here. Let me open. So this is my repository. I have already cloned it from yesterday. I'm going to open it in my code. Let me see if I have it already open. No, I don't. Okay. Oh yeah, there you go. I'm going to open my files in VS Code. Oops, do we need all this? Alrighty, so we had a simple file. I made little changes yesterday. It said this server is running on Docker. I just changed it to Kubernetes because we're going to run this on Kubernetes today. We had a Docker file, which basically tells the Docker how these are the recipe. This is the recipe to create the image. Remember, image is just a snapshot of my application on the right hand side. So all the files, let me zoom it. All the files on the right hand side, I want them to be into form into some an image which I can then containerize. So this is the recipe which I tell Docker to follow one by one to containerize my image. And yeah, I'm using Node to serve my application. This is my label. Copy everything from the directory which is on my system right hand side to everything to the source directory of my container. So container is an empty box. I want everything there, not inside any folder. Then I'm going to make sure I am in that directory. So cd is change directory, and then I'm going to install. Whoops, what is that? We don't need this. So I'm going to make sure I have all the packages installed inside the container. All of this is happening inside the container in the image. So I'm going to expose my port where I want to see the output in my browser, and then I'm going to put a command that change to directory, make sure you're in the directory, and then run my app. Now this is CMD is because I want this line to run when I start my Docker container, when I build a container out of my image. This runs while I'm making the image. So remember, image is the recipe, this right here, and it can make multiple containers. So you have the cookie cutter, right, which can cut cookies. That is the recipe. That is the image, right? It is just like how a container looks like, how your application looks like, and then you can make as many cookies as you want with that single cookie cutter. So that's what Docker images does. I just need one image. I can create as many containers as I want. Hi, Roxanne. I'm so happy that this is your first time knowing about Kubernetes. Feel free to ask any question, or if you missed out on anything else. Hi, Varun. Hi, Aribalan. So glad to see you all here. We have not begun into Kubernetes. I'm just talking about containerization, that we containerized our application yesterday. Let me check our image is there or not. So I'm going to run Docker image. It says list the images. That's what I do. Oh yeah, all the images. I have a couple of images, but at the top I have Ashwin exe GSW. I just updated it 9 minutes ago, so that is fine. Oh, this is okay. I can delete this one. There is an extra image. So in order to delete an image, this is a really nice tip. Okay, it's pretty messed up. Let me just, yeah. So image ID, all I have to do is copy the image ID, and I can say Docker RMI, which stands for remove image, and paste the image ID. Yep, that's good. Now if I run Docker image again, I should have only one image. Nice. If you were not able to create your own image, that is okay. You can pull down my image. So if I go to hub.docker.com, hi YR Singh, nice to have you here. So I have my repository, just like GitHub. I have my image here in Docker Hub, and if you copy this client, so if you go to this website, you will find, if you go to ashwini.exe/gsw, you will find this image, and if you just run this command in your system, if you have Docker installed, you will literally pull down my image. So let me just pull that for convenience. There you go. Okay, but you will say, hey Ashwin, I don't trust you. What if this is not the same image? You know what? Fine. Let me just delete my image. I'm going to delete my image and docker rmi. Oops, not this one. Yeah, deleted. I have deleted my image, so I don't have any image. I'm also gonna use the command. Could you please show the command to create image using docker CLI tool? It is there in the GitHub repository, I believe. Let me double check, triple check for you. So the command should be, okay, interesting. Oh yeah, they're right there. Oh, okay, there's some formatting issue. This is the command right here. Docker build -t, Ashwin exe, your username, image name. Let me just show you how to do that. So it's docker build tag. I'm going to add a tag that is where I want to build the image. That is my repository, my username, my Docker Hub username, followed by the name of my image. Could be anything. I named it GSW, colon, followed by the version number of my Docker image. So 1.0, 1.1, whatever that you like. So this is the command. Make sure you're logged in with Docker Hub in your CLI. But anytime you feel don't have doubt, you have like doubts, best place is like just Google it. So do docker build image CLI command, and the first thing that I get is the docs. And if I go here, it says the exact same thing. So it says docker build, and here's a nice example of building a GitHub container, a container from GitHub, and a couple of more stuff. So these are some pretty good examples here. Any recommendations for learning Kubernetes? Yeah, there are a lot of YouTube channels. I prefer documentation. We'll go through that in this stream. Documentation is one of my best because there are no ads. I can skip to whatever part I want, and just straight to points. I like reading, and documentation is the most trusted place. The official Kubernetes documentation is really good. Now, I just promised you I will pull my own image. So where's my Docker Hub? Whoops, not there. Not this one. Yeah. So I'm going to copy this image and paste it. Okay, I can also, yeah, latest version 1.0 is the latest. Waiting for it. It's pulling it. So a couple of layers were already in my system, so it only pulled a couple of stuff. How to check it? Docker images, and on the top, voila, it's here. If you have Docker desktop, you can all see it visually. I have it right here. I don't use it, but I just have it for convenience. So on the top, I can see I have my image right here. Cool stuff. I can run it via just pressing this single button, and it will run. So I don't have to use my command. I can just click on run. Let's just, for testing, let's just put my port 8080. So container port is 8080/TCP. That means inside the container, the port is 8080. I want outside to be 8082. So running it, it says it's running on localhost 8080. So let's go to localhost 8080, and there you go. It's running on not on Kubernetes right now, but we'll do that too. Right now, it's just running on Docker, a single container. If this container goes down, there's no way to stop it. It just fails. So I'm going to stop it for now. Now I'm going to enable Kubernetes in my system. If you went through the README and enabled it, that's fine, but it's very simple to start it. So I'm going to go to settings here, and it says right here, Kubernetes, and I have to enable Kubernetes. That's it, and apply and restart. So I have it already running. To see it on the left-hand side, if I just hover it, if I hover it on the shark, it says engine running. That is the Docker engine. On the right-hand side, it says Kubernetes is running. So if you start Docker, or if you just restarted and enabled it, it will be yellow and it will say Kubernetes is starting, and then it will start running. So these are the two things which are present in built the Docker desktop. That's why I like it. There are other ways to install Kubernetes. So if I just Google it, install Kubernetes. So I have install tools right here. The first one is, it says kubectl, uh, kubectl, kubectl, whatever, kube control, whatever you like to call it. People call it different words. So this is very important. kubectl or kubectl or kube control is the one that controls the Kubernetes cluster. So the whole thing is a cluster. Everything the user uh, commands whatever the cluster wants via kubectl. So kubectl is must. So you need to install kubectl. There are ways how to install kubectl on Linux, Mac, and Windows. For Windows, I think it will be an exe file or something. Yeah, there are a couple of lines that you need to run on your command on your terminal, command prompt. Quite a lot of ways you can install this. Let me just also paste this. If you feel doing it right now, if you're on Linux, it's a single command. A single curl command should be fine. I have kubectl installed. To check this, I'll just gonna open my terminal. Wait for it to open. Yeah, there you go. Kubectl. Yeah, it has installed. If it would say unknown command, that means it's not installed. So it's like kubectl. It will say something like this: command not found, but it is installed. Awesome. So I can talk to Kubernetes cluster via kubectl. Next, there is something called kind. If I read this carefully, it says it lets you run Kubernetes on your local computer. We are going to run our Kubernetes cluster on local computer because we can run it on cloud like Google Cloud, Azure, Linode, but we won't because most of them require credit card. And for demo's sake, I'm not going to go there. I have some credits for Linode, but since it will be easy for all of you to follow along if I'm doing it locally on my system. Kind. Hi, Akilik. Nice to meet you. So glad you're here. Hi, Dinesh. It's all right. We are just talking how to install Kubernetes today. Nothing, you have not missed out on anything. Everything is there in the GitHub README too, if you want to check up on previous day and stuff like that. So we're just going through installation. So have kubectl installed in your system. This is the one that interacts with me and the Kubernetes cluster. Second, something to run the Kubernetes cluster. So kind lets us do that. How to install this? There are a couple of ways to install kind. So there's package manager and whatnot. Hi Dinesh, you did not miss out on a lot of important stuff. We are just talking about going through the documentation. So here is the link. Just go here and you can follow me and just read it on your own page. That's fine. Minikube is also another tool that allows you to run Kubernetes locally, just like kind. So you can use one of them. You're not bound to install both of them. Minikube is more popular because it has some extra tools, but Minikube is pretty heavy. I prefer kind because it quickly spins up my cluster. Then there's kubeadm, which also does the same thing. So any one of these is fine. kubectl is a must. You need to have kubectl. I believe if you have Docker desktop installed, you don't need to install anything else. It has Kubernetes inbuilt. It says right here, and it should have kubectl installed already. If not, just type kubectl and check and maybe let me know because I have it installed. So I believe Docker desktop is one solution. If you are just starting out with Kubernetes, it has everything that you need. So you don't need to worry about installing A, B, and C's. I have kubectl. That is great. Now, which one do you recommend? Kind of Minikube? It depends on use case. So Minikube is a very popular choice for beginners. I prefer kind because it runs fast and is more light. But both are fine. So if you're on Mac, Minikube is pretty fast. So that also makes a difference. You have kubectl. I do have kubectl. Then you don't need to do anything else. If you have Docker desktop, make sure the Kubernetes engine is running right here. So I'm going to tell you how to check for that engine in a second. So this is done. Okay, we have installed Kubernetes. Now let's go back a bit of theory right here. All right. So Kubernetes is not a single tool. It has multiple parts in it, right? So the first part, the basic smallest element in Kubernetes cluster is a pod. A pod is basically a wrapper, like a toffee wrapper or just a wrapper of container. You know what is a container by now? A container is a replica of an image. So we have an image, that is the recipe, and we create something out of it. That is the container. It has everything we need. It has the application that we need running on it. A pod is a wrapper around it. It just, that wrapper is there to make sure it talks to Kubernetes. In fact, if I say pod, we can use pod and container hand in hand. So both almost means the same. Technically, they just mean the same. So pod or a container is the smallest element in Kubernetes cluster. We have, depending on the size of pod and or the size of cluster container, each pod has its IP address, which is unique to identify it, has its volume and the containerized app inside of it, which we can see it right here. This IP address is super important in identifying, what pod is doing what when we are working with Kubernetes. We don't have to worry about that. Kubernetes that does that for us. But you need to just know that pod is the smallest element, the most immediate important element in there. Awesome. After pod, a set of pods comes under a node. A node can contain multiple pods. So think of this like a hierarchy. Like you are a student, and a bunch of students form a class. Bunch of classes form the schools. Bunch of schools forms a school chain or a university, whatever you like to call. Node is where we have multiple pods running, multiple containers running. Why do we need multiple containers? What is a volume? Volume is the space occupied by that pod. So the way we say system volume, the volume of my system, gigabytes or in megabytes. So that is where the volume comes in. Now, each node has multiple pods. That is all I need to remember for now, that each pod has a container, or each pod is a container. A couple of pods form a node, or should I say a node contains pods. So each node is controlled by a node process called kubelet. No need to remember that, but each node has a process, and all of those nodes are controlled by the cluster or a single node called the control plane node. So that is also a node in the center right here. This thing is also a node right here, but it is called the control plane node. It was earlier called master node, but because that was not an inclusive word, it is called control plane node. That single node controls different nodes via its processes. And kubectl helps us talk to the control plane node. So all I'm doing is talking to the control plane node, do a XYZ, and it is doing that for me. The kubectl binary is not automatically packaged with Docker desktop for Linux. Oh, that's interesting. Then then if you're on Linux, then it should be a single line to install kubectl. That is fine. You should be good then. It's not packaged. Interesting. That's nice observation, Crypto. If you're on Linux, then what we can do is just go here, go to install on Linux. And I personally like curl, highly trust curl commands. So just copy this, paste it in terminal, and then validate it. I mean, it's official, yes, but you can validate it for sure. These are all optional commands, and this one is important. So install kubectl, and that should be enough. Yeah, this command we can run to test if my kubectl is up to date or to check the output version. You know what? Let me just check out the version of my kubectl. So if I paste this, see, I am on 1.25. So it says major 1, minor 2.5, 25. So it's installed on mine. So I'm good with that. But thanks for letting us know about that. If you're on Ubuntu, it's like a single liner, like sudo apt. Seriously. Awesome. Oops. Yeah, that's all the theory for now. kubectl talks to the control plane node, which is one master node or the main node, which talks to all the nodes. All the nodes have pods inside of it. All right, they have multiple pods inside of it running. Each pod is basically a container. So yesterday what we built was a single container. We were running our application on a single container, and now we want Kubernetes to manage that for us. I'm on Windows. I have set up Docker desktop. Do I also need to install kubectl? Can you check, open a terminal and run kubectl, and if it gives something like this, if it does, it's installed. Or you can run this command right here, which is giving the version of kubectl on your system. So let me just drop this link for you, and if it gives some output, that means it's installed. If not, you need to go and install it on Windows right here. Okay, it's installed for you for when. So Polar Void confirms that it should be installed. Just check it with the command, because we're going to start using that command quite often now. So pods, nodes. There are two things we are dealing with today. Nothing else more. One more thing, but these are the two major things we are dealing with. It is packaged for Docker desktop for Windows and Mac. Yeah, that's great. Awesome. You got it installed. So we're going to deal with pods and nodes. I can see what nodes I am running right now. So remember, I have Docker Kubernetes running right here. I can see it right here. It's running. But as far as I know, I just started with you. So I have no node or no pods running. I did not start anything. I turned off all the images, deleted all the images. So if the command to see what nodes are running is kubectl get nodes. If I click enter, it says Docker desktop is running, it's ready, and the role is control plane. Remember, control plane is the main node which controls all the node. So that one node is important. That is required for Kubernetes to run. If I turn off my Kubernetes in my settings, this will go away. And remember, the version is also 1.25, which we checked. So right now I'm running only one node. Let's see, am I running any pods inside? So kubectl get pods. Nope, I'm not running any pods. So it's only control plane node running alone. We don't have any pods running because we did not set up Kubernetes in my project right now. It's just running on my system. So I'm gonna go back to my project. Let's clear this out. Now I'm going to create a configuration file. Just like we have Docker file for recipe, which tells Docker what image to build or how to build it. Configuration file tells Kubernetes what to do and how to do. So I'm going to build a new file called pod.yaml. Something new we're going to learn today is YAML. YAML is a very friendly, very easy to read markdown language. I wouldn't say scripting language, maybe. It stands for YAML int markdown language, I guess. Let me just check. YAML stands for, yep, YAML in a markup language. It's a recursive acronym if you read it again. So recursive means it's defining itself. It's defining itself. So YAML in a markup language is YAML. And then again inside that is YAML, which is again YAML in a markup language, which is again YAML. So it's recursive and it's an acronym in itself. How cool is that? I don't know. The people are like amazing, those who made it. So very simple markup language. Remember, HTML is a markup language. It tells browser what to do. Just like that, YAML is a very friendly markup language. Yes, that's recursion. Recursion can do wonders. So YAML lives on very simple key value pairs. So you have key, you put colon, and you put its value. Kind of like JSON. If you are familiar with JSON, JavaScript object notation, you have like some key, you put some value, and then you some add values or stuff like that. The difference here is, in JSON you put parentheses or brackets. In YAML you don't put any brackets. You just add a key, and then you add colon, and then you add its value, and you add, let's say, key 2 and value 2. This is how I write YAML files. The catch here is, if I want to add, like how if we do it in bracket and add something else inside of it, in order to do this in YAML, it's like Python. I have to live on indentation. So indentation is a tab space. So I give the tab space, and if I add something like food, if I add apple or fruit, this fruit apple, this key value pair is inside Q2. So that's how it goes. Just like how in Python we put if and we put some condition, a greater than 0, and then we put colon, and then we put a tab. So that means it's inside the loop, or which is inside not the condition, or if it's outside the condition. So you have to be it can be a bit finicky, but you have to be very, very careful with indentation in YAML. It's the only annoying thing about YAML, but it really, really helps in the long go. Dictionary in Python, maybe I can say that. But so in dictionary you have multiple values, right? So if you add a dictionary and you add like a, and you add a comma, and then you add a b and stuff like that, or dictionary is like parentheses, I guess, and list is like that. In YAML, if I want to add a list, so I say, let's say, fruits. Instead of saying apple, comma, and stuff, I don't use that. I put a hyphen and then give a space, and then I start writing stuff. So fruits, I could have apple, 1, and then banana and stuff like that. So list, this hyphen means I'm about to start a list here. We'll be using these lists and indentations for some time. So it's pretty simple. Let me know if you have any doubts. Going great so far. Amazing. Now, I called it pod.yaml because this YAML file will have the instructions of how to create a pod and how a pod should behave. Pod can behave in many ways. I want my pod to be very simple. Remember, it's a wrapper around the container. I'll constantly remind of that. But instead of me following along, if I just do pod Kubernetes and open this first one, it defines what a pod is. And if I go down, this is the basic syntax of how a pod works. In this case, they're running it on Nginx. I'm running it on Node. So my container was running it on Node. They're running it on Nginx. Works. Could be Flask, could be anything. The first line says API version. Now Kubernetes, the control plane node, does not go to a node and say, hey, do this. No. Remember, everything is microservices here. So if I go to my slide from yesterday, let's see if I have slide from yesterday. Yeah. These arrows are the APIs. Kubernetes uses the API to talk to them. So the first one tells what version of API we are using. We are using first version of API in Kubernetes. That's by default. The next line is kind. What kind of YAML file is this? So we have multiple. I just talked. We have node. We have pod. We'll have our deployment. We will have services. So we are talking about pod. We are telling Kubernetes, this is a pod. Okay, keep that in mind. So I'm going to say API version v1, just like in the website. Notice A is lowercase and V is uppercase. This is called camel case. So we use camel case while defining our configuration for YAML in Kubernetes. Camel case all the time. What is camel case? If you ask, camel case. So if it's a 2-word letter, a 2-word variable or an object, instead of giving, you don't want to like add a underscore or anything. Camel case means the first letter of the first word is lowercase, while the first letter of the second word is uppercase. So like a camel hump. So hump is big, right? So Which OS I'm using? I'm using Zorin OS. It's a flavor of Ubuntu. So I'm technically using Ubuntu, but it just looks beautiful. So it's Zorin OS. A lot of people have been asking that. Is it really nice? Huh? Yeah, it looks pretty fun. I mean, it's smooth, so I'm happy. Kind. What kind of configuration is this, sir? Pod. Notice P is capital. This is some of syntax you need to keep in mind. If you face issues, I think the most of the time that I face issues, doing deployment and when creating cluster is like I misspelled V or I forgot to uppercase P. So these are some small things to keep in mind. I can copy paste it. That's also fine, but I'm gonna do it at my own pace. Next is metadata. Metadata is for my reference. All right. Just like website has metadata. Uh, so metadata, inside metadata, we can have name, we can have, author email and stuff like that. So name, now this is the metadata of the pod, right? So I'm gonna call it first pod. This is for my reference. When I'm running my Kubernetes cluster, it will show me what I'll see is the metadata out there. So this is for my reference. You can name it whatever you want. Do we get swags for completing daily challenges? You do get very unique Global Hack Week stickers for completing set of challenges. So keep an eye on that. I think everything is in Global Hack Week. If you go to GSW, I go to challenges. Yep. Keep an eye on these. Post this for you. You do get a limited set of stickers. It should be there in your email to see if you have won them or not, or you will actually know that by the end of the Global Hack Week. Awesome. So I called it my first pod. What's next? So next, let me just split screen it. That's easy. Next we have specification, specs. That's what I like to call it. What is spec? Now, spec is where, if you just read it carefully, it says containers and then the name and image and some ports. So before this is for my reference of building the Kubernetes, the pod. This part builds the pod for me, whereas the spec tells what container I want. So if I go here, give an indentation, I'm going to say, yes, I'm talking about containers. Oops, that's weird. Wait, with my internet? Or is it? My internet is fine. Okay, that's cool. Oh, we're back. Fine. So we have containers here. So here I'm about to define containers, my containers, and my containers. Again, there will be a list of stuff that I want to define, like name, image, and the ports. So that's why hyphen space. Now the name, the container that I am running is not Nginx. It's running on Node. Or in this case, I guess, yeah, I can name it whatever, but I'm gonna call it Node. The image that I want to run in my pod is ashwini.exe/gsw version 1.0. Let's double check here. Images. Yep, this is the image that I want to run. This image right here. So I mentioned the image. Next up, we have ports. Ports. Okay. Then there is a list. It says container port 80. No, I want 8080. What is container port here? The container port is the port which is inside the container. So remember, Kubernetes, they have nodes. Inside of that, there's pod. I'm creating a pod. So if I want an opening in the pod, inside my application is running on 8080. I want to open that, and to open that inside the container, I'm saying, hey, the container port should also be 8080, because that's what I said in my Node.js file, my backend file. So if I open my backend file right here, I opened it on port 8080. Where should we submit completed challenges? I believe it is also there mentioned. If you just slash challenges, let me open random challenge. Yeah, submit it on daily form. There's a form to submit it. It's also there on the mlh.io section, and it's also in your email, I guess, if you want to submit. Yep. Bishnuk is right. There's a form given. You can submit it there. Should be a Google form. Now, I told my so this should be enough. 10 lines. The API version of Kubernetes I'm using is one that is from the website. I'm following along. Kind is pod, metadata. For my reference, it's called first pod. The specification of the containers that I want to run inside this pod is the name will be node. The image will be GSW 1.0. That's the image that I built yesterday. And the ports I wanted to expose it is 8080 because that's what localhost 8080 was. Now this thing is exposed inside the pod. Not it's still not out of the Kubernetes cluster, so it will run, but it will run inside the Kubernetes. I will never know. There's no way to check out the output right now. Yes. Is container port 8080 in pod YAML equivalent to using -p8080 in Docker and command? Kind of, but when we use -p8080 in Docker, we can check out the output in the browser. Here, we are just opening that port inside the pod. All right. It will connect my application and the container pod. It will open that 8080 port, but for security reasons, Kubernetes does not use the 8000 range when we want to export stuff, and we'll come back to that why. So far so cool, looks good. I have saved it as pod.yaml. Now I want to apply this. I want to run this. Like, let's start creating a pod. I want so remember kubectl get pods. There's no pod right now. I want this YAML file to create my pod. So to do that, the command is kubectl apply -f stands for file. In Linux, F stands for force. You want to force stop or force delete, but here -f is file. I am applying a file called pod.yaml. It's also called YML, both works. So it's like HTML, HTML. So you can name it YML or YML. If I press this, it should create a pod for me, and this should be gone, and I should see a pod. Now, in fact, let me just run this right now. So if I do this, created, let's see, it's running. So I've applied, it says pod created. And if I see kubectl get pods, first pod, one by one, there's only one pod running, 1 out of 1 running, no restart, 2 seconds ago. Now it's 16 seconds ago. Awesome, we got a pod running in my system. Can I see it in here? No, because I don't think it shows pods in Docker desktop. So you have to rely on command line terminal. If you sometimes, create the pod too fast, like you created the pod and immediately you did kubectl get pods, you will see no output, or you will see creating, and then you will see this running. So creating pod takes time sometimes, and if you do get pods very fast, you may not see it. Let me show you an example right here. So I can open a split terminal. kubectl get pods is the command to see the pod. If I add a --watch, it will constantly do get pods for changes. So now this thing is running on the right, is constantly checking for changes. So let me delete or kubectl delete pod. first pod, the name of my pod. You see on the right, it's terminating that. Okay, it's deleting. Let's see. So let me just create it again. I just want to create it again and show you how a pod is actually created. It just not goes from 0 to 1. There's a couple of tiny changes happening before it goes to running status, and it happens so fast we can't see it. So I'm gonna wait for it to delete and give you a quick getting hydrated reminder. Stay hydrated, y'all. Okay, it's deleted now. Now let me just clear this terminal. Awesome. So assuming you're building it for the first time, you wrote your YAML file, you wrote kubectl, apply file pod.yaml. Look on, observe the right hand side. See, it created a pod with pending status. Then it was 0 by 1. So pod was not ready. Container creating. So it started creating a container. I told you, right? Pod is just a wrapper around container. So it's my container is running and the status is now running. Can I see my container here? I probably can. Yes. So if you see, the name is K8, which is Kubernetes, but the image is my container. So it is running inside my pod. If I delete my pod right here, again, it will go from here. Let's see. I'm gonna wait for this thing to delete. Oh wow, we're already half time already. Wow, amazing. We are pretty smooth on track. That's nice. Waiting for it to delete. Let's see. So after I create this pod, my container is running inside of it, just like Docker run. So that is happening inside my pod. It's deleted. Let's see if, oh yeah, it's gone. You see, only my control plane node is running and the the container is gone. So let me just show you graphically. Split screen, or I don't even need this. I can just use my terminal. I love using terminal. Like, it just looks nice. Just zoom it for you. Cube CTL. Oops, wait. Oh yeah. So cube CTL apply file. My file was pod.yaml. Created, and there you go. I have one of my nodes running, and in that, the file name, if you see, ashwini.exe/ghw. So my file is running. But if I open localhost right now, obviously it won't work because it's running inside the pod. All right, I need to find a way to expose that and show it on my browser. This is done. So far so good. Let me just expand this. So cool stuff. It's working so far. I have my pod running. Now what I want is to expose this. How do I do that? Kubernetes has something called a service. So I'm going to use a service to expose my pod. So if I just Google search what is service, I'll again see a basic standard format of how service is written. So this is how service is written. It's almost the same if you see. API version, the kind changes to service, metadata, and spec, we won't worry about what is there down here. It's pretty similar to this, but we're going to run on that. Now, I'm going to create a service. So to create a service, another YAML file. Let's call it service. Yeah, let's call it service local.yaml. Or let's call it local for ease. I'm going to tell you why, because we are setting up a local service and the documentation mentions how to set up it on the cloud. I'm sending a local service here. Which terminal am I using? This is native terminal. This is ZSH. So yeah, ZSH, and then I have my ZSH on top of it, and code auto completion. So if I write like git, you can see it's auto completing for me. If I do like /, it will complete stuff for me and stuff like that. So code auto completion, and yeah, these two things. This is also ZSH. Awesome. Where was I? Service. I'm going to build a service which will talk to my pod and expose that port, which is 8080, to my browser. So I want it out in the system, right? Uh, Again, API version of Kubernetes v1. What kind am I using? It's called a service with a capital S. Let's add some metadata, and we have more than one metadata. So I'm going to add name, and let's call it service local. Let's just add one metadata is fine. So that also works. Oops. Yep. So inside the metadata key, I have another key value pair. Specification. I hope you can see this. Let me just, okay, yeah, this is fine. Specification. If I go to the website and see what do they say, they have selector and some stuff, but we don't want that. The thing is, when we use target port, it's for if you're using Azure, Google Cloud, or Linode, DigitalOcean. All of these have a target port. You connect to target port, you tell this is the target on my cloud, and that where the Kubernetes will start pointing. So if you want to upload my website to the web, so I'll just point it to the cloud. Will the swag drop happen now? Not really. Swag drop may happen during the daily catch-ups. Feel free to stay if you want to learn about Kubernetes. We are doing like live hands-on, and it's going well so far. What I am interested in here is the type is going to change. So I'm going to use something called a node port. Node port is specially used if you want to node port Kubernetes. So if you're running locally, you need to use node port. So it's a service that exposes my node port. So if I just go here, and I should have an example right here somewhere. Let's see. I can also search it node port. Oops, without any changes. So yep, we are interested in exposing our app, and let's see. Oh, we have a nice interactive tutorial. I love tutorials, but we should have node ports example. I don't think we have it right here. Do we have it here? No, not for now. That's all right. I would definitely recommend using interactive tutorial. This will do most of the stuff for you. But oh yeah, we are going to do that. But I'm using node port. This is their node port is required for me to run expose my service locally. You don't need to use it if you have cloud credits, or if you're using it on the cloud. The port or ports, we have multiple ports, so it's a list. What is the port that my application inside is running? 8080. What protocol we are using? If you have some fair idea about networking, oops, space, you have to be very careful with that. The change in color makes you can help me identify if it is right or not. So this will be a wrong YAML file. So for local system, I can use TCP. TCP/IP is a standard protocol, so I'm using TCP protocol to expose my port. There's something called target port. So the target port in this, remember, is the container port. This is my target port. So I tell my service that this is the target. Look for a port which is open, and it's called 8080. So that's my target port inside the container. And finally, the node port. So it's automatically coming in. This is the port that I have to open on my local host. This is the port that will be exposed to my computer, which I can open in my browser. The problem with Node port is I cannot use 8080 or 8000 or stuff like that. Uh, why? There's the Kubernetes developers just for, you know, for our own safety made sure that it does not conflict with 8000, so they just change it to a range between 3000 and 2000. So I'm going to use 3000. uh, I can use 8080. I can show you how it goes wrong. Or actually it's not 3000, it's 30,000. Yeah, 4 zeros. The reason being, if you have something else running in your 8080, because 8080 is a very popular port, if you have React, it's running on 3000. So that can be a problem if you uh, run your cluster on 8080, because that will be busy. Hi Princeton, are you late? Kind of, you're halfway through the workshop, but you can stay and see what's happening around. I have all the resources in the GitHub repository. Let me drop it for you again. The recording will be available. This we are at day 2 of finally deploying our own Kubernetes cluster. We just made a simple, using our own simple web application, how I can run it in my cluster. So my node port is 30,000. This is where my local host 30,000. So this is where my application should work. Now, this should work, or should it? So here's the thing. Let me just try to run this. You know what? I'm gonna open my favorite terminal and say kubectl apply file service. Was it called service local? Yes. .yaml. Oh, it says right here. If I press this, some issue. What is that? Wait. Service in version can be specific for node port. Wait, let me see. API version 1, kind is service, metadata, name, service local, node port, ports is 8080, TCP, node port 3000. So what's going wrong here? It is an unknown field called ports. Oh, did I put ports? Oh, okay, wait. That should be fine. What's going wrong here? Let me put this as oops. Let's see if this works. Nope. Interesting. Do I have my pod running? Whoa, I don't want this. kubectl get pods. I have my pod running. Yep. Let's go back to the documentation and check once. Ports, protocol. Yeah, port 80. That's fine. That's good. Should not be a problem. TCP. Let's change this to 3111 just to be safe. Bad request. Interesting. Why is it happening? Let's see. So there is one problem that could be. Could you let us know the difference between port and target port? For sure, I can. Port is where my application is running. So my app.js is running on port 8080. So, oh yeah, you're right. Thank you so much. Camel case. Good catch, crypto. But let me show you the difference. Let me delete this. This is my normal app.js. So if I run node app.js, it will run on localhost 8080. That is my port. So my program is running here. Let me show you localhost 8080. It's running. This is my port. Target port is what is the port that we opened right here. So inside the application, then inside the container, and then inside Kubernetes. That's how it goes. Yep, I have written node port. You are right. It's small n. Thank you so much for catching that. Let's see if this works. Oops, nope. That's weird. Wait, okay, so actually it should be notepad because it's the value and not a key. But one thing that I believe is that I am strongly missing should be a selector. And I'm going to tell you what is selector right now. Let's see if this works. No, this is not a, okay, that's weird. Oh, API version, let me see if this works. Save it. Oh, okay. Probably a typo here. Interesting. Let me just delete this and save this. Yep, it works. Where was the problem? I guess I missed out on port here. Oh, okay. Yeah. Oh, yeah, right. So this one was capital N. Good catch. Thank you so much. Our configuration is there. To check it, kubectl. Remember we do get pods, we did get nodes, we have get services, SVC. So I have two services running. Pod has an identity list. Yes, you're right. So here, ports and so ports has an ports has list. So these are the key values inside ports. And I think I had a problem here, but it's fine now. Now I have two services running. The main Kubernetes cluster, you can see its cluster, it has a port. And then I have SVC local, which was, if you see it carefully, was the name of my metadata. Application port, Kubernetes target port, host machine, node port, that is correct. I will double check with that with the Kubernetes documentation too, and I'll add that to my README. Thanks for reminding me. So kubectl get SVC, we have Kubernetes and SVC local, which I just named it right here. In theory, this should work because the port it says is 8080, that is inside the Kubernetes in the container, and the external port is 31,111. So obviously this won't work. Localhost 3.1.1.1.1. Huh, interesting. What's wrong here? I did everything correct, right? I mean, I added all the ports. My pod is running. So kubectl get pod. That means my pod is running. That means my container is running. My program is running, and the port is out there. What is wrong here? Can anyone guess? Well, let me spill the beans. But I did not tell my service to watch the pod. There can be 3 pods, 4 pods, 5 different pods. Which pod to listen? So I can create, let me just go ahead and create a new pod, or yeah, pod2.yaml. Okay. And here we have some changes. Let's say, let's run something docker, docker images. What image? Oh. So what images do we have? We don't have, okay, let me just docker pull Python here. All right. So I'm going to run Python in one and my project in one. I forgot to tell my service which pod to look at. There is no correlation. If I put my service and pod side by side, can you tell one thing that is common in both? There is nothing common in both. How do I tell both? How do I link both of them? Whoops, I'm looking at the wrong pod, this one. So the Python is installed now. Yeah, so let me just run another pod, which is docker images, Python, and latest. Yeah, let me run that. So it is Python latest, and this is called pod 2. I'm going to apply this. So kubectl apply -f pod2.yaml. Yep. Kubectl get pods. Oh, it's actually a first pod. Oh, okay. I forgot to change the name. This is not first pod. This is called Python pod. Apply this, and let me also apply pod.yaml. Let's see. I have two pods running now. First pod, which is my global hack week project, and Python pod. There's no way to tell my service. So my service is also here. So kubectl get svc. How do I tell this service that look for a pod where my project is running and not the Python one? So I have to add something called a label. Now label are optional in metadata, but it is super crucial if you are giving an output, or if you want to check your application in a browser or even in cloud. Labels are super important. So I'm going to add a label here. Whoops. So I'm going to say it has labels. The first label I'm going to add, I'm just going to add one label, and let's call it event. And the event we are doing is GHW. All right. I go back to on the right hand side on my service, and I tell add a selector. The selector is look for that label. That label, go to that pod which has this label, and the selector is my label name event and the value GHW. Make sense? Here I added a label to this pod, this very unique label that only this pod can have. The pod, so if I go here, kubectl get pods, there are the one way to identify a pod is this, the name of the pod. But I can have same name for multiple pods. I'm going to show you that in the next stream. But one unique way to identify a pod is label. So I'm using that label, and I say to my service, the node port service, which is outputting my, which is exposing my port to my browser. I'm telling, look for the pod in the selector which has the this label event called GHW. If you observe, this line is common in both. This is the only key value which is common in both the YAMLs, the service and the pod, and that's how they will connect. Let me just go ahead and update my service. So kubectl apply file service local.yaml. It will update my service. It won't overwrite or stuff. Oops, some issues. Interesting. What is we have? Oh, let's see. Can we use event or let me just delete my kubectl delete service local.yaml. Oh wait, kubectl get service, not YAML, it's just service local. Oh, it's svc local. That's the name of my service that I gave in metadata. That's why metadata is so important. Deleted. Now let me apply it again. So kubectl apply -f service local, that is the name of my file .yaml. If it gives an error, oh okay, there's an unknown field in selector. Then you can, I don't think we can use events. We have to use something called project. Oops, project. This should work. I just change it events to project. Let's see. Oh, it's not that. I'm really sorry. God damn. Oh boy. So you have to be very careful with the indentation. So that's the thing about YAML. It's very annoying that, remember, I wanted my selector to be inside the port, not inside the port, inside the specification. I'm talking about a container here, right? I'm talking about the pod, uh, and it is not in the pod loop. So remember, this anything inside the spec is the specification of my container. So I am talking outside of it. So I'm just gonna give an indentation. That's why it was unable to detect it. Now whatever I'm saying is inside the container. So these are the specification of container. I say inside the container, look for this. Let me try this again. There you go. Service is created once again, just like that. kubectl get svc. Pretty simple. I don't see any change. I see same stuff, same IP, same port, but this time this service should typically be forwarding the port which is running this container. Let's put our fingers crossed and have some drum rolls. And whoops, it's not working. I'm not surprised because 3111 did not send any response. Interesting. Let's see. Interesting. I guess I have to delete my service again. So I've seen this happen before. Delete service svc local dot, yeah. Oh, yes. Yep. See if this applies. Close localhost 3111. Oh, interesting. What's going wrong here? Let's see. Let me rename this to projects because I have used project in the past, but that should not have any effect. Project. Let me apply this. Is my Docker container running here? I have my thing running right here. I can see it. I have Python running here, which I don't need. Yep. Interesting. So event, and this also should work. Let me see. Let's see if this also work. It's unchanged, yeah. Oh wait, kubectl apply. Oh, okay. Okay. I got it. What went wrong? I have fair idea. I updated my YAML file in the Kubernetes cluster, but I forgot to update my pod because which I also added a label. So kubectl apply -f pod.yaml. I have to update both of them. Oh wait, it's not it's unchanged. Let's see. Is this working? Nope. How is it unchanged? Let me then make some changes here. Let's see if this works. And if this works, oops. Okay. It's working. Yep. Interesting. I made some changes, but the pod are not updated. So I'm going to just delete this pod. kubectl delete pod. What is this? First pod? Yes, it is first pod. I'm gonna wait for it to delete. That happens like with the Docker desktop. It sometimes is slow to respond, or it just does not update pods at times. It worked for me even it is event. Oh, awesome. Were you able to open the local host? So event should work, yeah. I'm pretty confident. Yeah, 30,000. If you were able to open, if it said welcome to GSW, congratulations, you just ran it. I'm not gonna fall behind you. Just give me a second. I'm going to just catch up with you. I'm gonna delete service, or let me just see if I have any service. I do. Delete service. Yep, I don't have any service now, and I don't have pods. I have Python pod running, which is fine. Oh, there's a crash on my Python pod crashed. Let me just delete this then. Kubectl delete pod. Oops. No. Kubectl delete pod Python pod. Okay, I'm going to delete that, and now I'm going to create a pod. Kubectl get pods. Oh, apply -f pod.yaml, and then service. Start the service. Local.yaml. Go here. Interesting. It's not working for me, which is weird. This is done. This is 8080 31. It's fine if it's 31 31,000 or 30,000. Everything, anything works. Honestly, it does not really matter. But it's interesting. Oh wow, it worked for Crypto Black. I'm so happy for you. This is the first time in the history that I did not did, and you are. I'm so proud of you all. That is so awesome. I guess it's probably the problem of my Docker. Let me just restart my Docker. This has happened before. A couple of days before I tried that, I just restarted my Docker, and it just surprisingly started to work. Hydration reminder. So you can see it says engine is starting. Kubernetes is already running. Okay. Kubernetes is starting. Why are saying? Were you able to do it? Were you able to see the output in your container? So once I start my Docker, it's already here. Faraz Khan says, nice. I guess you also got it. Let's see. Interesting. I have my pod running here. Okay. Yeah, it's right here. Okay, let's try 30,000. Let's try how good luck is it. 3300. Yep. Oh, I'm on localhost 8080. Wait. Nope. Weird. No, that's wrong. All right. Let me apply this. kubectl apply -f service local.yaml. I've updated my service. Yep. Now it's on 30,000. Amazing. You also got it. That's so awesome. Now you can flex all that. Probably my Docker configuration in problem. Yeah, this has happened before. Because my configuration is pretty much all right. I got my service, I got metadata, service is local. Oh, looking at the wrong pod, sorry. I'm just gonna delete the pod too. Don't need that. Akilak, what problem are you getting? Just let me know. So metadata, I got a first pod, containers, it's type node. It's my image, port is right here, container port is 8080, and then took for 8080, TCP, target is right there, node is 30,000, selector is, wait, where is my label again? No, not again. Oh. Just keep messing around. How do I do that? You may not have made changes to pod 2 and a pod. Yeah, exactly. I just realized that. I don't know. So this gets so messy. But thanks for reminding me. Labels. Yes. Okay. Gonna apply. Oops. Take kubectl apply -f pod.yaml. Figured. There you go. Simple as that. It was right there. The answer was right there. Hello, GSW. This is running on Kubernetes. It's absolutely running on Kubernetes. Don't forget to check in. There's a check in link here. If you have not checked in for, oh, this is part one. I have to upgrade it to part two. Uh, but let me just drop the check in link again right here. Please check in if you want those some swags and win points for your community. Let me, where is the message? Copy. And yay! Thank you so much. We got it. This thing is running on Kubernetes. How cool is that? But what is cool in that? Let me show you something cool. So observe this very cool thing. Let me just split screen right here. So this one is my image, right? The one that is running here. So if I refresh, it's running. Let's say it goes down. If I just delete this, all right, it's gone. But let me just refresh again. It's back up. You see that? The moment I deleted the node, it came back up. It's right now indestructible. So if I just do this again, and if I refresh, it's back. Kubernetes is detecting that, okay, the pod is down, which should not be there. It again starts the pod on its own. Unlike yesterday, I had to use docker stop, docker start. It's running it on its own. Let me show you in a more terminal-ish way. All right. So instead of website, kubectl get pods is the command, right? Let me just, yeah, so you can see it more easily. Yeah. Yep. kubectl get pods with a watch will constantly watch for changes. So right now it's running. Let me just go ahead and delete this. All right. Watch what happens. Error, and it's again running back again. So that's one of the many beauties of Kubernetes. It constantly watches my pods. I don't have to worry about my pod. Right? We got it. I'm so happy some of you folks made it, were able to push host your Kubernetes cluster and put it out with that. It's all right if you did not. I'm going to, in fact, right now, let me just go ahead and commit this in the GitHub repository. I'm going to add Kubernetes YAML files. And there you go. I've pushed these files to the GitHub repository. You should be able to clone these exact files and they should work just fine. All right. But yeah, we were able to do it. So far, so good. Today we ran our own cluster on Kubernetes, which was the agenda. There are a couple of features of this. So I just showed you one of that. Let me just show you again. If I go down here, what we just experienced was self-healing, but not the Kubernetes way. So it was more of a Kubernetes default, but the real self-healing, it's kind of like this, but it's even more robust. We are going to experiment that too. And in the next stream, in the next part, the final part, which is more of playing around, we'll play around with Kubernetes and see why it's, you know, why it's a, why is it this term so popular out there in cloud native? Or if you have ever tried cloud native, or if you wanna, why Kubernetes is so essential. So automatic rollout and rollbacks, we're going to try that. Self-healing, and maybe if time exists in the next stream, horizontal scaling. But it's going to be a lot of fun. We'll do a lot of destruction of our pods. We'll destroy them and watch them just grow back again. We'll increase them, we'll decrease them, and or see Kubernetes do it on its own. But for now, I'm so happy that we are able to deploy our own cluster finally. Our cluster is running. It's right here, and our pod is running inside of it. There is a service which is taking forwarding the traffic, you know, from my container to my browser and browser to container via these ports. So there's container port, which is open inside the container, the normal port of my website. Target port is exactly what the container port is, and the node port, which is on the output. So if I put it 30001, that is also works. I have to put localhost 30,001. To connect these two, I need to have some relation, and that is the label. So label, whatever you like, call it event or anything else, and a value. make sure the selector is asking that. Now the selector is inside the specification because we are talking about containers here. So yeah, what do I think about Docker Swarm? I've not tried it yet, but there's Docker Swarm. There is Docker Compose, which we can use to containerize multiple images. I won't get into that because that's more into containerization. Our agenda was, we know containerization, just one way is fine, whatever way you like it. After that, we'll focus more on Kubernetes, but Docker Swarm is pretty cool. Now, that said, I guess we are good with the demo for today. But if you have any questions, I'll be around. Maybe I'm going to explore and play with my Kubernetes a little bit more. But you made it today too. I'm so happy that you did. And if you could not, it's been recorded. Watch it all over again if you like. If you want to know more about containerization, part 1 is your place to go. Part 3, we are going to play with Kubernetes. So part 3, we are not going to build anything new. We're going to have some more YAML files, or we're going to edit the existing ones and see what else Kubernetes can do. What are the like beauty of it? So yeah, maybe try different container on Kubernetes. You have your own project, containerize it. If you containerized it yesterday, see if you can run it today. Try different Kubernetes tool. I used Docker Desktop. Use Kind or Minikube. I like Kind. I like to play with Kind. It is not resource intensive, so you can try it out for sure. There's no harm in that. And play with YAML files. YAMLs are pretty cool and they're scary at the same time. You can see a single indentation got me into trouble. A single uppercase and lowercase issue got me into trouble. So play with YAML files if you want to. Day 3 will be at 5:30. I don't think so. No. So day 3 is going to be at Friday. Let me check that. So today we are at 7 a.m. ET, and the day 3 will be in Friday 8 a.m. That is 1 hour from now. So it will be at 6:30 p.m. IST. So 6:30 p.m. and it's going to be around same length, maybe shorter if we are able to wrap it up quickly, and we'll leave room for you know we'll leave room for questions. And if you're around and if you would like to showcase your Kubernetes cluster that is running right now, let me know. I would love to pull you up on stream. I can give you the stream link, and I would love to see your experience of deploying in Kubernetes today. If you want to do that, open a ticket in Global Hack. You can just tag me. Just tag Ashwin from MLH. Normally we don't say don't tag MLHs directly, but I'm saying tag me directly for now. That's fine. So you can join the stream right now. I'll just add you to the backstage, and I would love to see what did you deploy today, or if you did deploy, and what issues did you face. So next stream is going to be at 6:30 IST. Let me also grab you the registration link so you can add it to your Google calendars. Yep, this should work. This is for part 3. Make sure you're hard checked in for today. That is the part 2. All right. Sounds good so far. Does service also self-heal like pods? So service is an API. It does not go down technically because it is not working for Kubernetes. It is just transferring the instructions, right? So it's a really good question, by the way. Let me just check that out. Let's check it out. Does Kubernetes self-heal service? I don't think so. It says, yep. The straight up answer would be no, because Kubernetes looks for containers, and it is the containers that fail. A lot of reasons containers fail. Could be buggy YAML file, like I just made a wrong YAML file, container failed. Could be a lot of traffic, a lot of load. A lot of people are opening that particular. So if everyone in my home and everyone in this stream start opening my personal portfolio, which is not meant for that traffic, it will just crash. And that is a single container. So that could be a reason of failure. Could be due to some hardware reasons and a lot of reasons that containers can fail like that. And it is Kubernetes work to start a new container. What else do we have for today? Let me just see. Do we have any more slides? No. Today we learned about pods, nodes, Kubernetes cluster. Where should I tag you to get in? Oh, just create a ticket in Discord and just tag me in the ticket, and I'll just send you the stream link. I'm pretty sure the slides are also up there on the GitHub. Let me again put the GitHub ka link. Let me put the GitHub link again in case you missed it. All the commands here. I'm going to add today's commands. I mean, let me just add the place where you can find all Kubernetes command. Or honestly, documentation, best place. Like my favorite place. All commands are here. Everything. Wow, I can even check this out. Okay. Isn't also an example here. Oh wow, there's get. And then there is wow, so many ways. Beautiful. This is a great place to check out commands. Okay, I think we have someone coming up. Or let me just do one thing. We have only 21 folks. Yes, official docs are best except few. Official docs are best. I'll just stop right there. There are some other docs. DigitalOcean has great blogs. So if you just do Kubernetes DigitalOcean, I should get really nice Kubernetes docs. Really good docs to the DigitalOcean. Very easy to understand. Uh, just love it. Just quick start guide. Yeah, really easy to read. If you don't want to get into the nitty gritty and still understand what's happening, DigitalOcean has great dots. Blogs, you can read some blogs, but that just gives you an overview of what happens around. Uh, you know what? If we have only 21 folks, let me just paste the. Okay, maybe not. Do we have any? Okay, I don't have any tickets for now. We still have. We have around 10 minutes, I guess. Yeah, I mean, you can go to random articles to get some basic gist of what Kubernetes is. Actually, I think there is a very nice blog written by one of our coaches, Valya, on Kubernetes, which gives you a plain, gist of what Kubernetes is. Let me see if I have that blog right here. Yep, this one. This is a decent blog for any beginner to understand. How do I raise a ticket? Oh, you know what? Let me just drop the StreamYard link here. You can just join here. So this is a really good blog. uh, Basic commands. Again, what is monolithic microservices orchestration? How cluster works? Control plane node, worker node. The node which is working is called a worker node, and it's a pretty decent command. So this is a great blog. Let me just grab this for you if you are interested to read more about it. But if you are curious how to raise a ticket, let me just show you how that is done. So if I open my Discord right here and where is the GSW? Let me just find global hack week. There are so many channels. Oops. There you go. GHW. So if I go right here, you can see my Discord. If I go a bit up here, and I should be able to see something called FAQ. Is it an FAQ? No, it should be an MLHR ticket. Yeah, there you go. So there's a, oh, you can't see that. There's a ticket. It says MLH support tickets. So if you just go there and click on create a ticket, and it's gonna do, yeah, there you go. It started a ticket with my name, and this is how I open a ticket. A very handy tool if you want to, if you need help from MLH, which you typically don't want to ask in public. So generally, I advise, highly advise to ask in public. But if you're uncomfortable, or if you want to report something, or if you need, help, like, hey, where's anything like where's my spag drop or stuff like that, which you don't feel comfortable asking in public, ticket is a way to go. Ticket is the best way to connect you with MLHers, or even there's mentor ticket in hackathons. I'm going to close my ticket. Hope that answers your question. Awesome. Looks like we are good for now. We have done a lot today. We have covered a lot yesterday, and I'll just try to make sure to make it understandable in the next stream. Oh, we have crypto here. Hello. Hi, crypto. Can you hear us?
Yep. Am I audible?
Awesome. So, yeah, you are audible.
Cool. You want me to turn my camera on?
It's your call. That's fine. But so you wanna tell us what did you publish in your Kubernetes cluster, or how was your experience?
Yeah, sure. It's yeah. So since I've been working with Docker a lot, right, for many years now, but never got around to work with orchestration. So Form talking about still an orchestra, something lower head to Kubernetes, but it never. It just one question always runs through my mind: is there really a need to get this overhead over services? Because let's see, can I share my screen?
Yeah, sure.
So something like this. So I ticked off the advanced thing, right, which is given in the doc Docker desktop Kubernetes package, in
Okay. Is
which
it
you can
just
see
me
all the
that I
containers
can't
that
see
create.
your screen? I don't think I can see your screen.
Okay, 1 second. You can't see it entirely, or is it?
Is it? Oh, yeah, it's back now. Okay, it's probably my internet. I'm sorry. You can go ahead.
Yeah. So just these many containers for we what we did right now was these two, if I'm not wrong, like the node pod is what we did, like one service and one pod. But the overhead of having all of these, right? That is why I asked for something like Docker Swarm, because yes, it is much less feature rich when compared to Kubernetes, but it's very lightweight. As you like some of your as you like Docker engine instead of Docker desktop, just because it's light. It's same reason. So
Yep.
just wondering if it
Yeah, go ahead.
because whenever I see anyone, right, whenever they get into Cube Native or something, they hop onto Kubernetes because it is so hyped. Uh, just that questions wonders me so every time, every now and then that's why I didn't never started Kubernetes because I was like, there is no need, there is no need, there is no need, there is no need. And yeah, but it was wonderful. It was great. My 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 installation is what we did just now. I had a problem with the Python thing, but I'll solve it later. Maybe I'll push it over to the Discord if I solve it later on. And yeah, that's it.
Yeah, I do agree. There is always a technology hype in every domain. For cloud native, it would be Kubernetes. For web, it's like JavaScript. And for
Yeah.
Web3, it's like Solana. Uh, so here's the thing.
Yeah.
There's no need of Kubernetes. In fact, a lot of time it's an overkill if you're using it on to host a simple website like we are right now. uh, the real need of Kubernetes comes when we are scaling application, and it really helps a lot of startups who are planning to scale. If you uh, so there has been a lot of instances. So
Yeah.
here's one really good instance. I don't remember the name of the company. It was on Fireship YouTube. uh, so one of the startup
Yes.
ended up, they were using their cloud platform. It was AWS, and they were using it to run their product. And in one of the updates, they forgot to close one of the recursive functions and got a overnight bill of thousands of dollars. That was insane, just because they forgot to close the function, and there was no fallback policy in the AWS. Like, if you cross a certain limit, just stop running your instances. There was no way to do that. And they just asked the AWS team that this was a mistake, and you know uh, this was a mistake, and can we, like, just, you just not bill us that huge. And they refunded it. They were very nice. uh, but okay, I think we lost them, I guess. Yeah. uh, but if you're watching and if you're listening anyway, uh, the problem there was no orchestrator when, the team was sleeping overnight. So this is one decent example of why you need to automate it. But you don't need it necessarily everywhere. There are a lot of orchestration tools other than Kubernetes. And similarly, you don't need containerization all the time. But there are certain use cases, especially in DevOps. That's why it's whole part of DevOps. And in the cloud native space, it's decently used. uh, I have seen a lot of uh, imposter syndrome for Kubernetes. People are pretty afraid to learn, but it is quite easy, and once you know, it's quite fun too. uh, so for example, I have my own community, and when we are building its website, we earlier used Katra, which is like drag and drop, no code low code solution. And now we felt like we want to open source the website. And we know the traffic is huge on our community website. So we will be using Kubernetes because we want to save the cost, at the same time automate that deployment. So it has a unique use case, but there is certainly a use case. There'll always be a hype, and that is okay. Don't go with the hype. That's why I would always recommend asking people who have used Kubernetes to see how they learned it and why they learned it. Oh wow, we are back. But yeah, okay. Crypto, we lost you, I guess, for a second there, but that's all right. Yeah, that is a simple story. Any technology that you learn, join Global Hack Week to test them out. But if you want to, like, implement them, maybe, or maybe just get a deep dive, if you're like serious about cloud native and stuff like that, definitely ask a person who uses that tool for quite some time, and they can tell you their experience. So, Crypto, did we miss you out on anything? Okay, that's fine. That's all right. Uh, but yeah, I was just talking about one instance of where Kubernetes comes handy, and we are on time. I'm so happy that you're already familiar with Docker, so that gives you an edge. It's
Yes.
nice. So yeah, we'll hopefully see you in part three, and I'm going to wrap up before the next stream starts.
All right.
Awesome.
Thanks.
Thank you so much for joining crypto. We'll see you around. I'm
Absolutely.
gonna put you in backstage. Awesome. So thank you so much for all of you for joining here. We'll see you day after tomorrow, 6:30 p.m. IST. That is, yeah, 8 a.m. ET if you're in the West. And let me know if you have any questions in the Discord. I'll update everything in the README, and we should be good to go. That said, this was deploying your Kubernetes clusters part 2, and we will see you in the next one. Bye.